Welcome back, folks. I'm Chris, and we are going to continue our studies for part 3 laminations. And we're going to use an example because sometimes an example is sometimes the best way to really understand the issues. So basically what we're going to do is we've taken API 579-2, which was the example manual that was written in 2009, and then we're going to upgrade that to 2021 edition of 579. And then we're going to elaborate a little bit with some industrial experience that I've had and some of the published information that is available. So let's get started. So the first thing we're going to do, talk about the specific example in 579-2 is called example 13.1, and it's a level 1 examination, and basically the example shows it as a level 2, but really it solves at a level 1. So we just stop there to keep our video down to a minimum, and there's not much of a difference between level 1 and level 2. Secondly, so we're going to go through every one of the steps in detail, and I'm going to show you my spreadsheets the way I do it. And I love your feedback and how to do it. And I've used these spreadsheets quite often. It helps you do a very quick assessment. And so let's dig right in. So let's look at the problem statement. So what do we want to do? We want to perform a level 1 assessment per part 13. Now there's a very detailed description, but what I like to do is recommend is that we break it the givens in, what the process people provide, what the mechanical engineer provides, and what the inspection people provide. So let's look at the material, the construction, what the pressure vessel designer had done with this vessel when how he constructed it. So we have here the materials of construction, which is SA 516 grade 70 plate, which is a very commonly used structural plate for pressure vessels in the last 30 years in North America. The code of design and construction code is ASME Section 8 Division 1, and it's a pre-1999. So essentially, the allowable stresses are different. There's a few other little differences, but that's about it. I have a great video on the differences in these allowable stresses in our library if you'd like to take a look. According to the 2021 API 579-1, this is classified as a type A component. And in the 2021 version, they start to really, break it down. Is this a cone, or is this, shell, or is this a pipe? And they do that, and then they provide um, more options for it. In the old days, they didn't really take that much into account. But anyways, here, let's continue. So we have the inside pipe. It's 120 inch diameter, and it's or 3.03048 millimeters, which is the conversion of 120 inches. The nominal thickness is a half of an inch. The corrosion allowance is 3 millimeters, and the joint efficiency of the design is 1.0, and that's with reference to ASME Section 8 Division 1. The allowable stress is 17.5 because of the addition of the design. Process discipline. They have indicated that the design pressure remains at 125 psig, or 862, and we haven't we're working with that in this example, but oftentimes it could be lower. So the coincidental design temperature is 200 degrees centigrade, and it's not in hydrogen charging surface. There's no H2S, for example, in the service that can dissociate in water and form monatomic hydrogen, which can migrate into the steel, which is an essential element of laminations. And for more details, check out episode 1. Mechanical/metallurgical aspects of this design. So we determined that the system is not in the creep range, so we don't have to revert to the part on creep for this assessment. We have sufficient material toughness for the design conditions, which for all the parts, you have to initially check to see whether you have a brittle fracture issue or not for all the conditions, including the hydro testing and all that. And so you have to check for that. The second one is we check to see whether this was in cyclic service, and it's not. The internal loads pressures are govern, so that means that there's no the supplemental loads are negligible. That's like bending and so on. Inspection team found for us. They found that there are 2 laminations in the shell. They found that the 2 damaged areas were located away from structural discontinuities, and we in episode 1 we talked quite a bit about structural discontinuities, but they've indicated in the inspection report how far it is, which is acceptable. And like inspection is to me one of the most important thing, and that's the hardest stuff tends to get when we do evaluations, is whether the inspection report is complete as per 579. We know that the distance to the discontinuities is shown in the report, so the distance between each other. The distance to the nearest weld is shown in the report, and they found out for us that the loss there was no. So the vessel is in really good shape. It hasn't deteriorated. It's just that they found these 2 laminations. Please. Like always, we go back to part 2, look at table 2 and do an overview of the flaw and damage assessments. And so, we the design is shown here. It's pre-1999. We have the tag number, and all this would be found in the assessment. Should be organized. The pressures are indicated. Sometimes we'll have some wall thickness. We've determined the maximum operating pressure. For this example, we're going to use the same. There's no cyclic operation. We determined that one, and we're not going to worry about the liquid level in this particular example. And if not, we just adjust for that to where it is on the vessel. So we went through here. We saw that there was no brittle fracture, which would negate this right away. The other ones we found there was no general metal loss, because there was none. There was no metal loss detected. There was no pitting. There was no hydrogen charging, so we don't expect any part 7. There was no mention of weld misalignment to worry about. There was no cracks. We don't have a creep issue, so we don't have to review part 10, and so on. So there's no fatigue, and we don't have to go to part 14. The damage is, I don't know, classified as internal, but it's really not inside the vessel. It's internal to the part. So so the environment, there's an environmental pressure inside the vessel, so it's not going from the inside out. To part part 13 in the appendix, they have a table 13.1, and this is how they recommend to organize the information from the inspection report to do the calculation. And all of the abbreviations I follow exactly to API 579.1, so that everything is reproducible and comparable. So we've already reviewed the design code, the addition, the materials, the allowable stress is organized. We put the joint welded joint efficiency and all that. So we've organized all that information. We have the wall thickness, the LOS, the corrosion allowance, the future corrosion allowance, which is, because there's 0 there, you can go to this one. If you need more information on that, we have a section on corrosion allowance. And the RD wall thickness as a result is the same as the nominal after the inspection. Used to you table, or sorry, figure 13.2, typical lamination that's found in the fitness for service one. I left that out of episode 1 because it's more practical to put it here. And let's take a look here. This is a plan view of the elevation looking from the outside or from the inside. In that blue, great big blue blob you see there, that's the flaw. And so this is a critical dimension. This is S and C. And as we look in the plan view, then we're going to look at another one. It's called section AA, which is shown here. And this is where we talk about the planality of the thing. So if we have, as we saw in episode 1, if we have a flaw that's in the middle of the part and it's all on this plane through the cross-section thickness, then it's very less likely to be an issue. But if we have an LH, some height to that, then this is where we're worried about. So we're going to get, the inspection report, we've gathered this TM, which is the minimum height to the top. And then we've got the thickness, and then we've got our S and C values. And then we're going to put those together. Some more geometry we have for you. This is figure 13.3, the weld joint spacing for multiple laminations. Recall we're going to examine multiple ones. So then it's just straight math. We go ahead and S1 and C1, S2 and C2, and we have 50 flaws. We follow the same kind of accounting practices, and then we look at the distance LS, the distance between the two, because we're concerned about the fact that they can influence each other. But if they're far enough away, then it's not an issue. So then LW is the distance to the closest discontinuity. In this case, we have a weld. Continuation of that part 13 table we showed earlier. And this is where the inspection report should have this kind of detail where we talk about the different the flaws. So the way I usually do is I do it on a spreadsheet, and I have lamination identification up here, and then if I need 3 and 4, I just extend my spreadsheet to the right. So I used figure 13.2, which we saw earlier, and then we tabulate all the values, and of course the edge-to-edge spacing between the nearest lamination there, it's 11 inches, and it only applies to this one, so that's why I said between 1 and 2. I have a minimum measured thickness, which is found shown in figure 3.2, and the nearest distance to the weld joint, and then away I go. Kind of interesting. I recommend going to step 5 first. In the 2020 edition, they've put this procedure to step 5, even though in steps 2 and 3 you need this value. So basically, we're just adjusting for the the corrosion allowance and what's future corrosion allowance and so on. So just be aware of that. I'm starting at 5.2 to be perfectly step 5 to be perfectly aligned to the 21 edition. The early editions don't have that issue. They moved it earlier. I don't know why they did that, but they did. So step 5 is recommended to be completed, you know, earlier so that you can get to step 1 and 2 and do the calculation. The early either 13.3 or 13.5 may be used. Now, this is common throughout all the parts. They've moved like different sections or the different parts of API 579. They've created a new section called 13.4 and 5, and it's the same equation, but I think they've done that for convenience, which is fine. We begin, we always do like a screening check, because what's the point of doing all the math if you're going in the wrong direction? So we did that table 2.1 before, and this is a final check to make sure that we don't have to go to other sections in the code. So the first question, and I've referenced this 13.2.4b1, for example, and I'm not going to continue that, but here's an example. Lamination does not exhibit evidence of an associated surface bulge. So that, that's associated with, hydrogen charging and we have in other sections we have the effects of hydrogen and blistering. If classified as a surface bulge, then it needs to be characterized as a blister, and then you need to go to part 7. Basically, then you don't use part 13, okay? And then the second one is, if the component is not in hydrogen charged surface, the components with lamination, you have to go back to, part 7 for that. Is the original design criterion accordance with the code or standard? That's a standard question asked for every part. I've never seen anybody not do this, but it's about following the recognized codes. Does this material have sufficient toughness? Now that's going back to the part about the whether it's we have enough toughness in the part, whether it's a brittle situation. Is a component non-cyclical service? Yes, and we have the types of flaws, and we've determined it was a type A. And if we have piping, then we can, there might be another way to do this. So if we have type A component and we have then basically we go and we say for level 2 assessment, if we're going to do that, we can go a type A and a B1 components of internal pressure supplemental loads, therefore that. So then there's some notes on there about if you want to continue to a level 2 assessment. We want to check to see whether these two laminations that we found need to be combined. And so we combine only if the following criterion is met. There has to be has to be at least 2 on the same plane of laminations, that is, and the spacing does not satisfy the 13.1 equation, which is shown here. And so we continue. So if combining is required, then the lamentations S and C shall be adjusted accordingly. Okay. Items to check whether they need to be combined. The assessment required as an equivalent HIC damage per part 7. If we have greater than 2 laminations on 2 different depths of the wall thicknesses. If the spacing does not satisfy 13.1, which is showed in the last table. Ready to begin our calculation. So I've organized everything so it's super clear on my spreadsheet, and I have a step 2 change if indication is required through the thickness cracking. So then this is the calculation we check to see whether they need to be combined, and we found L is greater than 0.875, so it's true. So we conclude that the lamination does not need to be combined into a single larger element. In the assessment, there is no indication of through thickness cracking. that we found earlier. And when you look at table, the episode 1, if we have cracks, in my experience, when we see laminations, then we basically repair it. We don't try to assess it most of the time. 3, we're going to check the distance to the nearest discontinuity to see whether, that stiffening effect and the local stresses as a result can affect the evaluation of lamination. So we have this equation, and this equation is the same one that we use for dents. And we do the assessment where this is a given value in the inspection report. So we have 42 inches, which is greater than 13 inch. So we are true. So the distance between the localized bending stress to or the nearest structural discontinuity and the closest lamination is acceptable. So we can continue our evaluation of level 1. So we're going to continue here with step 4, evaluate the through thickness of the part. And basically they have a couple cookbook equations, and both of them must be satisfied. In this case, we meet both of them. So the way I did it in my spreadsheet is I use a very similar method. I just have lamination 1 and lamination 2. I do the checks for LH, right, which is, how far, how close, like that's how non-planar it is. And so we feed that into that equation, and we look at S and C, and we determine that everything passes, so we can proceed to step 4. Proceed to the next step. I'd like to mention a couple things about equation 13.3. If it does not pass, then we need to evaluate the through thickness as a crack-like flaw, and then we should be going to part 9, level 1 assessment procedures. Okay. Another issue is we need to, with part 9 checks, we should be checking the crack depth, where A1 is equal to LH, and then we use that to feed into the calculation, and then the crack length is 2C is equal to the maximum of S and C. In step 6, we do a few more checks. The first check we do is we check to see whether the inspector has found that there's no indication of through thickness cracking whatsoever. And the first question answer is yes, so we can continue. Then there's another case where we look at the lamination is not surface breaking in accordance with this equation. So we take the Tmin, it's got to be greater than Tc. And that's equation 3.6, and the breakdown just shown here. And you can clearly see that Tmm is much greater than 0.004, so we're true. The third check is LW, has to be the maximum of these. And we do this run through, and we are okay. So we can continue. And so let's look at the conclusion then. So the calculation passes. So let's proceed to step number 7. Final check here, we're going to look at the maximum allowable working pressure, and we're going to use this equation, and we're going to use the TC values here. We've got for determining either, we're going to go to Annex 2C331. No need to go to the pressure vessel code. Everything is contained within 579 for convenience, which I really like. The older codes, I should mention, it's not annexes, it's found in appendices at the end of the the chapter, but we're basing this, of course, on 2021. So as long as we meet these conditions, we can use this maximum allowable working pressure equation, which is, the pressure must be equal or less than 0.385 SE, and we satisfy that criteria. We're not really sure about whether this has longitudinal joints or not. So we're going to check it. The inspection report didn't give it. We didn't go that much detail at that point. So we do that calculation, we find that it's true. So then we go ahead and we do the final calculation, and we're allowed to use 2C-10, and we get 127 psig, and then we can conclude that the component with the lamination is acceptable for the operation at this calculated MAWP. So we are done. The design is acceptable per level 1, and as per the code, we don't need to continue to level 2. If there is a need requested due to level 2, I can certainly assist you with that. So we are finished this example found in this example manual. Take care. I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.